Alright, this is the Geometry 1 triangle congruence unit. Here's the review. This is my key. So, we're going to go through item by item on this. So for number 1, it says given that triangle A prime, B prime, C prime is a rotation of triangle ABC. So it's already stating that this is a rotation, so that's important there. So that means that we're going to prove that they are congruent by a rigid transformation. So it has to be rigid. So we're going to go through and we're going to identify where these are located at. So if we're looking at this, and we're going to make rules out of this, and I'm going to show you how that works. So let's start off with A. So if I go A, the location is going to be 2, 3. And A prime is going to be at a location of 3, negative 2. Now, let's go with B. So B is at a location of 2, negative 2. And B prime is at a location of negative 2, negative 2. And C is at a location of, that is negative 1, negative 4. And C prime is at a location of negative 4, positive 1. So we're going to go through this and try and take a look at the reason why. So if I'm looking at my two values here, I have my x and my y. So I'm going to come up with a rule for this and see if that works all the time. So if this is my x, this is my y. So if I look, there's my 3 there. So now my rule is going to be the y goes in the x spot, and the x comes over here in the y spot, but it's the opposite. So comma negative x. And if that rule works out every single time for all these, then it is going to be a rigid transformation. So the first thing, so now that we have this, so the y value should go here, so that's negative 2, so that's correct. And right here, this becomes, that's positive 2, negative 2, that's true, negative x. So it's the opposite of that, that's good. Right here, I have negative 4, there it is, it's the y value goes first. And then right here, it's negative 1, and there's positive 1, so it's the opposite of the x. So this is going to be the rule for this. So this is proving, so all those right there means that it is going to be a rigid transformation. We did this before with the transparency or the patty paper, but we could just go through and look at the coordinates and make a rule, and let's see if it actually follows the rule. If it follows that rule, then it is a rigid transformation all the time. So now for the second part, it says, is angle B prime congruent to angle B? Explain why or why not. So we proved that they are congruent. We already proved that they're congruent. So if we prove that they're congruent, we should know that corresponding parts of congruent triangles are congruent. So since we stated that they are congruent already at the very beginning, says is the rotation of here, and because of this, are the triangles congruent? Yes, they are congruent, so I should put in a yes here. Yes, congruent. So we proved that they're congruent, but since all the triangles are congruent, so that one and that one are congruent to each other, therefore that we can go back and use corresponding parts of congruent triangles are congruent. Okay, let's take a look down there. All right. Now for this next one, for each of the following pairs of triangles, explain why they are congruent. So, keyword, they are congruent. Why they are congruent. So, this one right here, this nice pretty shape right here, going to make an X. So I'm going to have a vertical angle here and here. So since I have vertical angles, it's going to be a side angle side, side angle side. Now right here, they share this side right here, so I'm going to call that a reflexive. So since they both share that, it is going to be angle, side, angle, angle, side, angle. So there is going to be something missing, and you have to pick it out, like the vertical or the reflexive. Part C, AC is a perpendicular bisector. So this is very important. Perpendicular means that it creates 90-degree angles. So I'm going to have 90-degree angles here. Bisect means cut into two equal parts. So my equal parts are going to be here and here. And because of this right here, since they share this side, it's going to be congruent to itself. And because of that, I'm going to have a side angle side. Side angle side. So just because I have perpendicular bisector, it gives me all that information there. So if I'm taking a look at this, it says angle D is 40. So that's 40. And find the measure of DAB. So DAB. So it's going to be the big one up here. So a couple things we know here. So we know since that is 40 degrees right there. Now, in these type of things, I know that it is going to be they are going to be congruent. So that AD is going to be congruent to AB. We've already proved that they're congruent using side angle side. Now, if this is 40 over here, so overall the triangle itself, so let me trace out the triangle itself, the big triangle. The big triangle right there. So if this one right here is going to be 40, let's look. The legs of the big triangle I did in red are the same. So that means that this is going to be our isosceles triangle. So if that's isosceles triangle, so that means that the legs are congruent. So I use the analogy in my class that, the pants. So in the legs, when you have the pants on, the legs, then the shoes are the same. So the shoe are going to be down here. So that means the shoes are the same. So have the pants on, shoes the same. So that means this one is also going to be 40 degrees. Now the rule for that one is that base angles are congruent when you have an isosceles triangle. So if that and that, all part of the big triangle, that's 40. So now I know that all three angles in a triangle have to add up to 180. So I'm going to go with 40 plus I don't know. I'm going to give it an X equals 180. This is going to be right here at my angle A. So it's going to be 80 plus X equals 180 minus 80. So X is 100 degrees. So that's going to be this whole angle right here. And that's the one we're looking for. So DAB. So that right there is going to be 100 degrees. All right, number 3. Given the following segment AB, construct and name its perpendicular bisector. Okay, so I got my handy dandy compass here. So let's see right here. All right, so now when I do this, if you recall correctly, so I'm going to start by stabbing B, and if you notice, I have paper underneath it to try and hold it in place. So open it up more than halfway. So here's more than halfway. Draw my arc. I'm going to stab A. Do the same thing without changing its shape. So that's important there. There we go. So I have my arcs there. Now, I just realized I cannot find my ruler. Alright, so next closest thing to a ruler is a straight edge, some type of straight edge. So I was going to use my ID, but you really don't want to see that picture. All right, right here and here. So I'm going to draw my straight edge with this. There we go. I have my straight edge right here. And so let's see, given the following segment, construct and name its perpendicular bisector. So what are we naming it? Doesn't say what we're going to name it. I'm going to name it, let's see, something. Explain how right here. Okay, so I'm going to name it P, Q, and M. So right there, I have labeled all the points, went along with it, and made up some happy points to go along. So anyway, so B says, using your construction, explain how any point on the perpendicular bisector is equidistant from the endpoints of the segment. So this goes back to the perpendicular bisector theorem. So in perpendicular bisector theorem, so any point on this line, because this piece and this piece right here, so I could use this to always come up with side angle side. So that should be an L. A L W A Y have for all triangles that are made with the perpendicular ULA bisector. So every single time that you end up with perpendicular bisector, you'll always end up with side angle side. So if I put a point right here and I make triangle to there, these pieces are going to be the same. Okay, and so this is going to be reflexive, perpendicular, it's going to be 90. So it's going to be a side, an angle, which would be 90. And side will be reflexive because it's going to share no matter where I put it on there. Okay, all right, let's take a look at 4. Given the following diagram, fill in the reasons for the following proof. All right, it says PM is a perpendicular bisector of XY. So I'm going to underline keywords. So first one should always be given. So PM perpendicular bisector SECTOR of XY. And that was my given. So with that information, I know that I'm going to start off with this right here. That angle YMP and angle XMP are 90 degrees. That's definition of perpendicular. Okay, now the next part states that so right now if they're both 90 degrees, so I'm going to actually mark that in there too. So if they're both 90 degrees, we know that angle YMP and use an and symbol, angle XMP are congruent. That's a congruent symbol. So that's going to be, here's 2, 3, and this is all right angles are congruent. So we have that one. Now, because it is bisector right here, we know it cuts into 2 equal parts, so this one and this one will be congruent. So I'm going to say that Y m is going to be congruent to x m, definition of bisector. Okay, so that's that piece. Then I have PM congruent to PM, and that's going to be reflexive. And now what we have here, we have that these two triangles are now going to be congruent by side, angle, side. So we're going to have triangle, let's say YMP is going to be congruent to triangle XMP, and the reason is going to be side, angle, side. And my last statement right here is going to state that PX congruent to PY. So PX congruent to PY, and my reason for that one is going to be corresponding parts of congruent triangles are congruent. So as soon as I'm able to say that they're congruent to each other, I can now go through and say all the pieces are going to be congruent to each other. There we go. Now, this next problem says, given an isosceles triangle, explain the theorem that if two sides of a triangle are congruent, then the angles opposite those sides will be congruent. So there's so many things to go along with that. That's actually the definition of isosceles triangles. That would be base angles are always congruent. So because of this, again, legs, if I'm wearing pants on my legs, my shoes are the same. So base angles are always congruent. So right here, so that's definition of isosceles. I know it says up here somewhere, because I keep messing up how to spell isosceles. I saw something. Not Solisa. There it is. Isosceles. Ha! I got it. Okay, so definition of isosceles. So it's always there. It's been proven. It's always proven, and you could just rely that has already been proven for you. So all you have to do is state in the first place that it is an isosceles. Therefore, base angles will always be congruent. So now for this one right here, given the triangle below, find the value of x and the measurement of each angle. So first thing, we know that all angles inside of a triangle have to add up to 180. So on my math right here, I'm going to go with 8x minus 1 plus 3x plus 9 plus 3x plus 4 equals 180. So that's that one, and that one together. All the angles have to add up to 180. Even though that they're variables, even though it looks like a mess, they all have to add up to 180. So whenever I find x and plug it back in, their values will come out to be that much. So let's do our x's. So we got 8x, 3x. That's going to give me 11x plus 3x is 14x. I have 1 plus negative 1 plus 9. So that's going to give me 8 plus 4 is plus 12 equals 180. Subtract 12 from both sides. So 14x is equal to, let's see. So 180 minus 12, which gives me 168. And take that number and divide it by 14. So that gives me 12. x is 12. So now I'm going to plug it back in. So this says 8 times 12. That's because x is 12 minus 1. So this piece is going to be 95 degrees. This right here is going to be 3 times 12, because there it is, plus 9. We get 45 degrees. And 3 times 12 plus 4, I get 40 degrees. So when I add those up, when I add all those together, so it's going to be 95 plus 45 plus 40 gives me 180. There it is. I did my math right. Alright, so let's take a look at this next one over here. So number 7. It says, given acute scalene triangle, triangle ABC, construct the medians. So we're going to go through and we're going to do midpoint of each and then connect it to its opposite vertex. So stab here. So open it more than halfway. There we go. I got that one. Using my straight edge. Between here and here. Maybe a point right there. And I'm going to connect that one to my vertex, which would be this one right here. There we go. Here's one of them. I have to do it for all of them. So I'm going to turn this around, hoping you can still see this. Okay. So, stab. I'm going to shrink it a little bit, so not too big. There we go. There we go. There's that midpoint. So now connecting the peak to that midpoint. Now I'm going to do it again for my last side right there. No, not right there. Hoping you can kind of see it. There it is, right there. So go. Stab it here. There we go. So we have here, here, there we go. And then if I did this correctly, all my points connected a central vertex would be there. And my central point is called the, that's the point where you guys actually say it, but centroid. Alright, using constructor to find a centroid and explain its characteristics. Now the centroid is, so it is going to be the center of the triangle. And in the centroid, all the medians, the ends intersect at that point. Next one says construct and equilateral triangle. So I'm going to start by stabbing the center and measuring it out. Measure out the radius. I got that there. So now pick any spot, stab, and just make it arc where that previous one intersects. That's the stabby point. There we go. And now, since this is going to be an equilateral triangle, I do not connect every point. I only connect every other. Skip one, go here, skip one, go here, skip one, end up back there. And my last one, which would be there we go. There's my equilateral triangle. And very important thing, some people I've actually seen do this, they erase their marks. You get graded by those marks. You need those marks there. Okay. It says right here, okay, I could prove relationship geometric figures using congruence criteria for triangles. So if triangle ABC is congruent to triangle CDA, which of the following must be true? Circle all that apply. Now, AB, so the first two here, is congruent to CA. So the first two here is CD, so this one is not true. BC, last two, congruent to DA, that one is true. So they have to be in the same order. CAB has to be in the same order. So that would be, since it's CAB, it should be ACD. ACD, that is also true. ABC has to go CDA. CAD, this one is not true. It's not in the right order. So we only have those two. Given the following diagram, which of the following statement must be true? Circle all that apply. Now, I'm going to point this out because it is kind of a mess. So I'm going to trace. I have a blue one here. And the other triangle I'm going to do in red, which is here. So there's my two triangles. So KJL has to be congruent to, so that would be, so if I do it in the same order, KJL, that would be LMK. This one is not the same order. JL should be MK. There it is, that works. JLK, that would go with MKL, not MKL. JK, so JK congruent to, the other one should be ML, not ML. JLK, so JLK should be MKL, that one works. So corresponding, they have to go together, they have to match, same order. So find the value of x and the length of BF. So knowing that CB is congruent to CD, CB is congruent to CD, we know that these two pieces are going to end up being congruent because this is angle, side, angle, angle, side, angle. So these two pieces are equal to each other. So I should go 6x plus 3 equals 4x plus 9 minus 3 minus 3. 6x equals 4x plus 6 minus 4x minus 4x. 2x is 6. Divide by 2. X is 3. Find the length of x and BF. So x and BF. So if x is 3, BF is this piece right here. So it's going to be 6 times 3 plus 3. That's 18 plus 3, so that's 21. Says a kite frame consists of 2 pieces of wood placed alongside a diagonal. Decorative binding will be placed along the perimeter of the kite. Okay, so that's important. So if it's around the perimeter, okay, around the perimeter would be here, 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 and here. That's in green. I did that for a reason. Okay, all of it's going to be green. So that's what I have to do. I have to find all those values. So now, a couple things I need to deal with. First thing, it says that right here, 12 inches in a foot. That's important. I'm identifying what I need. Okay, binding cost $1 a foot. What is the total cost? That's going to be my question I'm looking for. 2 pieces of wood placed along diagonals. Okay, binding placed perimeter. Okay, so right here I know that this is going to be 15. So given this information right here, I know that this is going to be 15. So if this is 15 and this one's 15, so they are placed along diagonals. Okay, so with this information, I know that this is 15 and this 15. So I'm just going to draw another triangle out here so you see it. 15 and 15. So I could use my Pythagorean theorem to find this one right here. So it's going to be 15 squared plus 15 squared equals c squared. So do my math. So that's going to be c equals, so you guys should come up with c is about 20.2, or I'm sorry, 21.2, and this is going to be in inches. Okay, that's important. So that piece right here and that piece right there is also 21.2. There we go. So that's part of it. That's part of it there. So now I know that this other triangle, which I'm going to show you in red,